This is the second of two videos for Algebra 2 for the practice test 7. Last we left off, we did problem number, I think 22 is the last one, which means, yep, we're on 23. And then we're going to do all the way through 33 in this video, and our answer key is right here. All right, jumping into number 23, just as a way to remind you, 7-10 is where this lesson came from. In order to complete the square, I'll explain it a little bit more in depth in 23 and then go fast in 24. We're completing the square, which means I have a square, meaning that both this side and this side are the same length. So over here we have, or we know that the area is going to be y squared, so we can label y squared. Y times y gives us y squared. And we also know that 42y has to evenly be divided along these diagonals based off of our diagonal trick that we learned in class. So we have a 21y here and a 21y here to add up to a total of 42y. And the question is, what is this number here that completes the square? And to find that, we need to find the side length. So 21 times y is 21y, so these both lengths are 21. And this number in here is going to be 21 squared. 21 squared. Well, I don't know 21 squared off the top of my head, but I know that I can do 20 plus 1 quantity squared. That's going to be the same thing as 20 squared plus 2 times 20 plus 1 squared. And I can do 400 plus 40 plus 1, so it must be 441. So 441 is my answer to number 23. And then in number 24, again, the quicker way of doing this without making a picture is you just take half of this term, half of the coefficient, 15 over 2, and then square it. So your two-step procedure is take half, and then step number 2 is square it. So what is 1/2 of 15 over 2? Of just means multiply, right? So half of 15 over 2 is 15 over 4. Okay, and then I'm going to square it. So if I have 15 over 4 and I square it, that's the same thing as doing 15 squared over 4 squared. And 15 squared is 225, and 4 squared is 16. So my fraction is going to be 225 over 16. What about for number 25? Not fill in the black. I want to go to blue. We need to complete the square for these, and the answer key is going to be a little bit unhelpful here. It might help you with the perfect square, but the answer key kind of oversimplifies, so I'm guessing you're here for the video just for these problems, if any of the problems on the practice test. First of all, we need to make room for completing the square. This is going to be a number that isn't going to be negative 35. Let's move negative 35 to this side so we have room to complete the square. I'm going to add 35, add 35. That was a terrible 5. Try it again. To both sides, and pen, yeah, I'll leave it on a fountain pen. Maybe it's the pressure sensitivity will bring down a little bit. When I do that, I have an 8x squared minus 16x. I have some room now to complete the square, and that's going to be equal to 25. Before I complete the square, I need to make sure that my coefficient out here is not a number, so I need to divide everything by 8. So let's go ahead and do that. If we divide by 8, divide by 8, divide by 8, and I'm going to get x squared minus 2x, and that's going to be equal to 25 over 8. I'm going to just leave it like that. Okay, now I'm ready to complete the square. So again, completing the square, as I showed you with my two-step process up here, is you take half the middle term, then square it. Oh. So half of our middle term. Half of negative 2 is, I'll write it over here, it's half of, my handwriting is like, I think I'm going to change this all the way down. There we go. Half of negative 2 is negative 2 over 2, which is negative 1, and then I square it. Negative 1 squared is 1. So that's the number that completes the square. A positive 1 completes the square. I'm going to add that 1 right here, and I'm going to add that 1 right here. I have to do it to both sides of the equal to sign, right? So on the left and to the right of the equal to sign. And then from here, I'm going to, I guess I'll do this one more in depth without skipping steps. I have an x squared minus 2x plus 1, which is a perfect square. This is the same thing as x minus 1 quantity squared. If you're curious about how I got this minus 1, it's always going to be this first steps number, or half of this middle term will come down here, and it's going to be that quantity squared. On this right side, I can't just add 1 because that's 1 over 1. These denominators don't match. So I need to multiply this 1 by 8 over 8. So this is really going to be 25 over 8 plus 8 over 8. And 25 plus 8 is 33. So this is going to be equal to 33 over 8. And then from here, I can just solve. So I need to undo this square on both sides. So I'm going to square root the left side, square root the right side. That's not enough. I need to do a plus or minus, so plus or minus. And then from here, things are going to cancel out. Gone, gone, gone. I'm left with x minus 1. And then over here, I have the plus or minus root 33 over 8. That's all under the square root, so I should be careful about my square root and say the entire thing there is being square rooted as opposed to just the numerator. And then finally, we just add 1 to both sides, add 1 to both sides, so that 1 is gone. We get our final answer that x is equal to 1 plus or minus the square root of 33 over 8. The answer key on the back doesn't say that, which is kind of annoying. I'm pretty sure the answer key tries to make everything over the same denominator. So the answer key does this dumb thing where they multiply both the top and bottom here by 2 over 2, which they're allowed to do. So this becomes 1 still plus or minus square root of 66 over 16, and then from there they do 1 plus or minus the square root of 66 over the square root of 16, and then 4 over 4 is the same thing as 1 plus or minus square root of 66 over 4, and then finally they get 4 plus or minus the square root of 66 all over 4, which is super dumb. It requires a ton of extra steps, and I already wrote an email to the developers of the software saying that this is super unnecessary. Please leave your answers like this from now on. Please, please, please. So I guess I can box that as well, although it leaves an icky taste in my mouth. Moving up to problem number 26. Kind of the same thing. Leave some room for completing square. This one's going to be a little bit more fractiony. Let's subtract a 9 from both sides. Subtract a 9, leaving us with n squared minus 11n is equal to 1. Okay, it's time to complete the square. I'm going to add a number to this, not 1. I'm going to add a number to both sides. The number that I add to both sides is going to be the thing that completes the square. So I'm going to take my negative 11. I'm going to take half of negative 11, like this. And then I'm going to say that's really negative 11 over 2. So that's step number 1. And step number 2 is to square it. I take negative 11 over 2 and I square it, which is the same thing as doing the top squared over the bottom squared. And that's going to be 121 over 4. So that's going to be the number that I add to both sides. I add a 121 over 4. I add a 121 over 4. And on the left side, I'm going to skip a step, and I'm going to say it's going to be the quantity of something squared here. It's going to be n minus, again, it's the answer from step number 2 down here. It's going to be this 11 over 2. This is going to be equal to, and I need to add these two numbers together, but this number is not being divided by 4, and this one is. So to add fractions, they need like denominators, which means our one up here needs to be multiplied by, let's do a different color, multiply by 4 over 4, and now this number is just 4 over 4. So 4 plus 121 is 125, and that's still being divided by 4. And it's now time to take the square root of both sides. So I'm going to square root the left side. I'm going to square root the right side. Don't forget your plus or minus, plus or minus. All those things cancel out. Gone, gone, gone. And you're left with an n minus 11 over 2 is equal to plus or minus a square root of 125 over 4. And then from here, we just add the 11 over 2 to both sides, plus 11 over 2, plus 11 over 2, and my final answer is going to be n is equal to 11 over 2 plus or minus the square root of 125 over 4, which again, the back of the answers probably says, oh, I can pop out the square root of 4 to make it a 2 and make it all divided by 2. I'm going to guess that's what that back will do. I haven't actually taken a look, but I think they're going to do 11 over 2 plus or minus root 125 over 2. Because this piece right here was the same thing as the square root of 125 over the square root of 4, and the square root of 4 is just 2. And from there, I'm sure that the back will say it's 11 plus or minus root 125 all over 2. I'm just curious. What I would box in my work for this class is I would box that, but I'm thinking that this is what the back of the answers say. 11 plus or minus 125. Oh! No, they won't say that. I know why. Because we can reduce this. And you should be reducing it in my class. Root 66, I didn't say it out loud, but that can be reduced. Or it cannot, 66 cannot be reduced because I do a factor tree for the square root of 66. That's just going to be square root of 3 times the square root of 22. Square root of 22 is the square root of 2 times the square root of 11. None of these factors matched each other. They're all different numbers. If I had like another 3 and a 3, then I could factor something out, but 66 didn't have any perfect squares that factored out. However, 125 definitely does. So how do you do that? I have the square root of 125, and that's going to be the square root of 25 and the square root of 5. square root of 25 is exactly equal to 5. Don't forget to bring down this square root of 5. And I really need to be turning that into, here, I'm going to move some things down. You all can move down a little bit. And I need to erase my bar here and say that this is going to be n is equal to 11 over 2 plus or minus 5 root 5 over 4. And then from there, I need to change all of our, whoa, my knuckle hit it twice and it did that. So these all need to change to 5 root 5 and 5 root 5. 5 root 5. This is the answer that I think will be in the back. So the answer that you should have in my class is right here with the reduced radical, but again, they're asking for a bunch of extra work. So I'm thinking that's what they're gonna have in the back. Let's check. So this is problem number 26. Check it out. Problem number 26 is right here. And yeah, it's 11 plus 5 root 5 over 2. So we did get that. They like to put everything over a fraction, which is why I knew they would have to do all this work to get that 4. And that's why this is a square root of 66 instead of a square root of 33, which really confused me when I first saw that looking at another student's paper. Then we're on to number 27. We can see, hopefully we have a square root of 37 that pops out. Let's see if that actually happens though. Number 27. Again, we want to clear out this 11 to make room for completing the square. So I'm going to first subtract 11, and I'm left with 3r squared minus 20r is equal to negative 21. And then from there, I need to divide everything by 3 because I need this coefficient to not be there when I complete the square during this process. So divide by 3, divide by 3, divide by 3, and I'm left with r squared minus this gross fraction 20r over 3. And that's going to equal to negative 7. From there, I'm going to complete the square. Again, that's a two-step process. Step number 1, you're going to take half of the middle term. The middle term is a negative 20 over 3. So that is going to be, notice that these are going to cross cancel. And let me show that gone, and that turns into just a negative 10 up here. It's going to turn into a negative 10 over 3. And then step number 2 is to square it. So I have negative 10 over 3 quantity squared, which is the same thing as negative 10 squared over 3 squared, which is going to be, parentheses there if I need to, 100 over 9. That's the number that I'm going to add to both sides. So when I do that, I have plus 100 over 9 right here and plus 100 over 9 over here. Notice that this negative 7 is not being ready to add to this fraction because they don't have the same denominator. One's a denominator of 1, one's a denominator of 9. So to fix that, I need to multiply this by a 9 over 9. And a lot of things are happening. Let me go a little bit slow here. I have an r squared minus 20 over 3r plus 100 over 9 on the left-hand side. The right-hand side is going to be a negative 63 ninths, because that's this right here, the negative 63 ninths, and then plus 100 over 9. Okay, from here, I'm ready to write this in the squared form, where I have r minus the half of a step. So it's going to be the 10 over 3 coming down here, right? So I have the 10 over 3, and then this is going to be equal to, time to do some subtraction, 37 over 9. Okay, now I need to square root both sides with a plus or minus root, plus or minus root, and things are going to cancel. Ooh, I want to do it in a different color though, so it's easier to see. Cancel, and I'm left with r minus 10 over 3. That's going to equal plus or minus square root of 37 over 9. And then from there you add 10 thirds, I'll put that in green, plus 10 thirds, plus 10 thirds, and I get r is equal to 10 thirds plus or minus the square root of 37 over 9. 37 can't be reduced. 37 over 9 definitely can't be reduced. So that would be the final answer in my class, but I don't think that's what the answer key is going to say. The answer key likes having the same denominator. This can pop out and become a 3. So the answer key will probably say r is equal to 10 plus or minus square root of 37 all over, okay, the 9 becomes a 3. Yeah, so they're both 3. Let's check. It was 10 plus or minus square root of 37. 10 plus the root 37, 10 minus the square root of 37, all over 3. So that is what we got. But again, in my class, I'm just expecting to get down to the box that I put around right down here. Excellent. On to the last page of the practice test. Solve each equation with the quadratic formula. So I will write the quadratic formula once, maybe twice, just to remind us what it is. And I will sing it as well. Here we go. X is equal to negative b plus or minus square root b squared minus 4ac all over 2a. And I would like to make this note. This fraction has to be underneath the negative b, and it is not underneath the x. X is on its own side, and on the right side is this giant fraction. I've seen a lot of mistakes on the last quiz where this fraction is only, like, some people will do this. They'll have the fraction only right here, and some people will do the opposite, and they'll have this fraction all the way over the x. I'm going to take off points if you're doing that. The fraction has to be the correct fraction. What are a, b, and c? Well, a is 1, b is 3, and c is negative 54. This only works when we have a 0 on the side. And notice in number 30, number 30, we have to first get a 0 in order to set up our quadratic formula. So just plugging in our a, b, and c, and I'm going to get the following. I'm going to get x is equal to negative 3 plus or minus square root negative 3 squared minus 4, 1, negative 54, all over 2 times 1. All right, so we just need to do some simplification. What do we have here? So notice I have a negative times a negative, which is a positive, so there's going to be a plus sign in between here. This is always going to be a positive because it's going to be squared. So inside the square root is where I like to start. I have a 9 plus something. How do I do 54 times 4? Well, really what I'm doing is 54 times 2 times 2. 54 times 2 is 108. 108 times 2 is 216. So this is going to be 9 plus 216. And I still have a negative 3 plus or minus out front, and I still have a 2 in the denominator, and that is still being equal to x. 216 plus 9 is 225. Square root of 225 with a negative 3 plus or minus out front over 2. And I'm running out of room here. I'm going to erase these guys. Oh, I want to go back to stroke eraser so it's faster to erase. And this is going to be still x is equal to that. X is finally going to be equal to a negative 3 plus or minus. Okay, square root of 225 is 15 all over 2. And I can't really reduce that, but I can show you the two different answers that will be on the back. So in one case, we have negative 3 plus 15 over 2. And in the other case, we have negative 3 minus 15 over 2. So negative 3 plus 15 is 12, and 12 over 2 is 6. So negative 3 minus 15 is a negative 18, and negative 18 over 2 is a negative 9. I'm sure the back of the answer is going to say 6 and negative 9, but in my class, you can leave it right here. I'm fine with that. So let's check 6 and negative 9 for number 28. Number 28, 6 and negative 9, we got it. All right, and on to number 29, which we invaded that territory a little bit, so I'm going to move these guys over a little bit. Hopefully that's enough room. Let's do number 29 now. So again, make sure that the right side is 0, which we did. And now we're going to say that A is 5, B is 4, and C is negative 3. Remember to include the sign in front of it. Because this was a positive, I forgot to, purposely didn't circle it, but the negative is important for the C. So again, I'm kind of singing the Pythagorean theorem in my head as I write this down. X is equal to negative B, negative 4 plus or minus square root B squared, 4 squared, minus 4A, which is 5, C, negative 3, all over 2A is 5. All right. And immediately I see a negative times a negative is a positive, so there's going to be a square root in here with a plus in between. 4 squared is a 16, and I'm going to do 15 times 3, or sorry, 5 times 3 first and get 15. Times 4 is a double-double. So I had 15, doubled it is 30, double it again, I get 60, so the answer here is going to be 60. So I get 60 in here, and then I have a negative 4 out front with a plus or minus. I still have a 10 in the bottom. This is still being set equal to x. And x is equal to negative 4 plus or minus the square root of 76 all over 10. 76. I think maybe there's a perfect square there, like a 4 or something. Let's see. Square root of 76. That's going to be the square root of 4 times the square root of... Can I do the square root of 4? I think I can. That's going to be 19, I believe. How did I know that? I knew this number was really close to 80. And 80 divided by 20 is 4. So I went a little bit less than 80. I got 19. And then I just multiplied it back up in my head really quickly to make sure it worked. And it did. So this turns into 2 root 19. So on our next step, I'm going to say x is equal to negative 4 plus or minus 2 root 19. And that's going to be all over 10. And that might be the final answer, except for the fact that this number, and this number are all divisible by 2. So I'm going to divide all of them by 2. Here we go. This is really going to be x is equal to -2 plus or minus just the square root of 19 with no number out front, all over 5. That should be the answer that's on the back, I would guess. -2 plus or minus root 19, plus or minus then root 19, all over 5. That's looking correct. We're on to one of the hardest, well, I think the hardest problem was still number 27, but the hardest problem out of the not completing the square, but the quadratic formula is upon us. So I was really hoping that I could divide. There's sometimes you can divide by 6, divide by 6. I was like, oh, if that's 18, I could divide by 6, but you definitely can't divide 17 by 6. Sometimes you can divide all these by a number to make your problem easier. That is not the case right now. The only thing we can do is make sure that this is a 0 by subtracting 8 on both sides. When I do that, I have 6p squared plus 6p, and when I do minus 8, I get plus 9. Oh, check it out. We can make our problem a little bit easier. Each of these can be divided by what number? They can all be divided by 3. That makes our problem so much easier. So when I do that, I'm going to be left with 2p squared plus 2p plus 3 is equal to 0. Okay, now this is going to be, my a is going to be 2, my b is going to be positive 2, and my c is going to be positive 3. Here we go. X is equal to negative b, negative 2, plus or minus square root b squared, 2 squared, minus 4a, which is 2, c, which is 3, all over 2 times 2, a. All right. And I don't have any negatives over here, so this negative sign is going to remain. And I'm going to have the square root of 4 minus some things. So I like to leave my 4 until the very end because I like to double it. 2 times 3 is 6. Double that is 12. Double that again is 24. And then I still have a negative 2 up front, plus or minus that, all over 4. And from here, I have this is equal to x. From here, I can come up here and say this is going to be negative 2 plus or minus the square root of negative 20 all over 4. And from here, let me think. Square root of 20, square root of negative 20. First of all, that's going to turn into a I square root of 20. You kind of take out the negative and it becomes an I. And then I can do a factor tree for square root of 20, right? The square root of 20 is the same thing as square root of 4 times the square root of 5, and the square root of 4 is just 2. So the answer is going to be 2 square root of 5. So really, I have a 2i square root of 5 here. So it's going to be negative 2 plus or minus 2i square root of 5 all over 4. And notice that u, and u are all divisible by 2. So our final answer is going to be negative 1 plus or minus 1i, or simply I, square root of 5 all over 4. And all these things, technically, this is x is equal to this, technically x is equal to this, and finally x is equal to this for my final solution, negative 1 plus or minus I root 5. There it is. Negative 1 plus or minus I root 5. I root 5. Nice. All right. Last 3 problems. These are kind of straightforward problems. You're just doing the discriminant. Just remember that the discriminant comes from the Pythagorean theorem, the quadratic formula. This thing right here, b squared minus 4ac. So I'm going to write down b squared minus 4ac. And this assumes that we have this thing set equal to 0, which is not the case here and not the case here. So that'll be my first step, is to set that equal to 0. And then we can just start plugging in, because 1 is my a, negative 9 is my b, and negative 10 is my c. So I'm going to have a negative 9 quantity squared, negative 9 quantity squared, minus 4 times 1 times negative 10. And I'm trying to see, is this thing positive, negative, or 0? So I'm going to have an 81 minus, plus. Here's when we have a plus. Negative times a negative is a positive. And then 4 times 1 is 4, 4 times negative 10, or 4 times 10 is 40. So I get 121. That is, the name of this thing is the discriminant. It's the thing that we're asked to find. And the discriminant is greater than 0, and that means that we have 2 real solutions. And often I'll just say just 2 solutions. That's if we assume everything is real, then the answer is just 2 solutions. But I think the back says 2 real solutions, doesn't it? Doesn't say, yeah, it says 2 real solutions. So I'm going to just try to match the back as much as I can. But again, in my class, it's okay to eliminate real like that. Number 32. Again, we need to make sure you are on this side. So I have a 5x squared plus 5. equals 0. You're noticing that I left a space here, and that's because we technically have a plus 0x. Remember that if you don't have an x, you can put a 0 here. So what is our a, b, and c? Our a is 5, our b is 0, and our c is positive 5. So we have b squared, 0 squared, minus 4ac. And that's going to be not equal to anything. So this is going to be, I do this because I know how to multiply by 4. It's a double. 5 times 5 is 25. Double that is 50. Double that again is 100. And I get negative 100 here. Again, the negative came from this sign down here. Did you know that negative 100 is less than 0? It's a negative number. If it's negative, then you can say one of two things. On the back of the answer key, or on the answer key on the next page, I should say, the answer will say 2 imaginary solutions. However, if you limit it to the real dimension, you're not allowed to go to the imaginary. That means you have 0 solutions. Either one of these is fine. I'm going to box both of them. Most students in my class say 0 solutions, and we restrict our domain to just real numbers. All right, finally, in number 33, we have a problem that we need to move our 1 over to the left by subtracting 1, and I get negative 4x squared plus 4x minus 1 is equal to 0. So let's analyze. We have our a is equal to our negative 4, b is equal to our positive 4, and c is equal to our negative 1. So it's going to be b squared minus 4a and c. We're going to check. So negative times a negative times a negative is a negative. There's going to be a negative left over. I have 16, and I just need to worry about multiplication. 4 times 4 is 16. And 16 times 1 is 16, and this is 0. Did you know 0 is equal to 0? If it's ever equal to 0, then we have only one solution. And technically, it's one real solution. They're both the same thing. I don't remember what the back says. Does it say one real solution or one solution? Probably one real solution, right? It does say one real solution. Again, either of these is fine. If you want to say one solution or one real solution, they're saying the same thing, just different domains, and we don't have to talk about the domains for these. That's a topic for another day, and that completes our practice test for Algebra 2. Thanks for watching. If you're about to take your test, good luck. I'll see you guys later.